All right, let's take a look at number 6 to 11 on this sheet that you have, sheet number 2. Number 6, a steel drum which weighs, so I'm giving you the FG there. So FG is equal to, what was it, 176.58 newtons. Is sitting on a steel floor. I can just imagine pushing it and the scraping of the... Coefficient of static friction between the drum and the floor is 0.9. I bet it is. Be like worse than fingers on a chalkboard. And the coefficient of kinetic friction, so this one's static, coefficient of kinetic is 0.72. Okay? And the first question wants to know, calculate the force needed to get it moving. So in order to get it moving, the force you have to push with needs to match the maximum static frictional force. So first we need our normal force. So some of the forces in the y direction. This steel drum is not moving in the y direction. So it'll be Fn equals Fg equals 176.58 newtons because they gave it to us. Okay, so then we can do friction is equal to mu Fn, and we can find our static frictional force. Mu static was 0.9 times 176.58 newtons. So the static frictional force should be 158.922 newtons. Okay, so this is my static frictional force. So now the question says, figure out the force you need to push with to just get it moving. And remember we said when you just get something moving, means it's not actually moving yet, and MAX is 0. So it'll be F minus friction, static, is equal to 0. So for part A, the force you need to push with is 158.922 newtons. You have to match the static coefficient of friction. It'll be just about to begin to move. When that happens, it'll switch to kinetic, and it will move. So then B says calculate the force needed to accelerate it at a rate of 2 meters per second squared when it is moving. So sum of the forces in the x direction will equal MAX, and it will be F minus friction is equal to MAX. We're looking for F, so take your friction to the other side, so it becomes plus friction. And remember, friction is fun, so it's plus mu Fn. So F is equal to, oh, we didn't find our M, but we can. It's M is going to be Fg divided by G, and I think you get 18 kilograms. So 18 kilograms, and the acceleration they told us was 2 meters per second squared. The mu for kinetic was 0.72, and our normal force was 176.58 newtons. First term is 36, second term is something bigger than 36 that I don't want to do in my head. And you should get an answer of 163.1376 newtons. That is the force you need to push with to keep it moving, accelerating it at 2 meters per second squared. Okay, so that's number 6. Number 7 says the acceleration of a moving 400 kilogram car, so 400 kgs, Fg will be acting down, Fn will be acting up, and the acceleration is 0.55 meters per second squared. And the frictional force acting on the car, so friction acting backward, is 80 newtons. What must be the applied force on the car? So what must be the forward force? And the second part is, what is the coefficient of friction? So if we start where we always start, some of the forces in the y direction equal to MAY. The car is not moving in the y direction, so it will be Fn minus Fg equals 0. So Fn equals Fg equals mg. And you could find this 400 kilograms times 9.81 or you could wait and go into the x direction. So sum of the forces in the x direction is equal to max, and there's F minus friction is equal to max. And in part A, you're looking for this F. So F will equal max minus friction. So F will equal 400 kilograms. The A is 0.55 meters per second squared, and they told us friction, it's 80 newtons. So 0.55, so 55 times 4, so 220 minus 80. 220 minus 80 should be 140. Oh, wait, oh, it's plus when you take it over. So 220 plus 80 should be 300 newtons. That is part A. Part B wants to know what must the coefficient of kinetic friction be. So you're looking for mu. You have Fn, or you kind of have Fn, I didn't actually find it, and you have friction. So use your fun equation, equals mu Fn. So mu is equal to friction over Fn. So 80 newtons divided by 400 kilograms times 9.81 meters per second squared. Mu is equal to 0.0204. So that's like 1 over 5. Okay, that's number 7. Number 8. A 40 kilogram box is being pushed across a level floor by a force parallel to the floor. Okay, so not at an angle yet. It's 40 kilograms. If the coefficient of friction, mu, is 0.25 and the acceleration is 3, what is the force the box is being pushed with? So 3 meters per second. This is